Welcome, everyone. Today, we're going to dive deep into the engine room of modern AI. We're going to demystify all those core building blocks, breaking down the essential terms that every builder, every developer, really anyone curious about this stuff needs to know. So, let's get right into it.
All right, to kick things off, let's start with the most fundamental question of all. When you type something into a chat window, what is actually happening inside the machine? Right? How does it go from just a bunch of letters on a screen to a meaningful, coherent answer? Well, our whole journey starts with a single word.
First up, we've got to understand how a machine even learns to read. And look, it's not magic, not at all. It's a really methodical process of breaking language down into tiny little pieces it can work with, kind of like how we have to learn the alphabet before we can even think about reading a book.
It all begins with something called tokenization. Now, this is way more than just splitting sentences by spaces. A smart tokenizer sees a word like, say, eating, and it gets it. It understands the parts, the root eat, and the suffix ing. By breaking words into these meaningful little tokens, the model can suddenly see the connection between eating, dancing, and singing. This is the absolute first step that lets an AI grasp the building blocks of meaning, not just a random series of letters.
Okay, so we've got our tokens. But how does the AI know what they mean? That's where vectors, or what we call embeddings, come in. The best way to think about this is like a giant, super complex map of language. And on this map, every single word has its own coordinate. Words with similar meanings like king and queen, or dog and puppy, well, they're placed really close to each other. This literally turns language into math, and that's how the AI can understand relationships between words.
But what about words that have more than one meaning? Think about the word apple. Is it a fruit, or is it a trillion-dollar tech company? This is where the attention mechanism becomes absolutely critical. It's a breakthrough. It looks at the context, words nearby like tasty or revenue, and it uses their location on that language map to kind of nudge the Apple vector toward the correct meaning. This is the secret sauce for how AI truly understands context.
Okay, so the AI can read and it can understand context, but how does it get so good at predicting what comes next? Well, that all happens during training, where these models learn at a truly mind-boggling scale.
There are really two main ways to go about it. You've got supervised learning, which is kind of like having a human teacher for every single question. It works, but it's really slow and expensive. The real game changer is self-supervised learning. This is where the model basically learns by creating its own puzzles from all the text on the internet. It'll take a sentence, hide a word, and then try to predict what that missing word is. This lets it learn the patterns and structure of language all on its own, which makes it incredibly scalable.
So here's a really crucial point, something people mix up all the time. A large language model, or an LLM, that's the final product you interact with. It's the car. The transformer, that's the specific architecture that powers it. It's the engine. You see, a transformer is built with these stacked layers of that attention mechanism we just talked about. That's what lets it process and understand incredibly complex relationships in text, and it's what makes today's powerful AI even possible.
Now, a general-purpose model is amazing, but its real value, especially for a business or a specific project, comes from tailoring it. So, how do we turn this jack-of-all-trades into a master of one?
You've got two main options here. Fine-tuning is like sending a general model to medical school. You actually retrain it on a very specific data set, like medical documents, to permanently teach it the language of a specialist. Few-shot prompting, on the other hand, is more like giving it a cheat sheet right before a test. You just provide a few examples in the prompt to guide its response, but you don't actually change the model. For any developer out there, knowing which one to choose is absolutely key for balancing cost, time, and performance.
And this is where things get incredibly practical. How do we get an AI to answer questions using our own private internal company data without having to retrain the entire thing from scratch?
The answer is this brilliant process called RAG, which stands for Retrieval-Augmented Generation. So when a user asks a question, the system first searches a special vector database of your company's documents to find the most relevant info. Then, it augments the prompt by just adding that info right in as context. It's basically like giving the AI an open book test, but using only your company's books. It's a super powerful way to use your own private data securely.
All right, now let's make a big leap. Let's move from models that just talk to systems that can actually do things. This is the evolution from just giving you information to autonomously taking action.
And that brings us to AI agents. An agent is so much more than a chatbot. It's an autonomous process that can automate entire workflows. Think of a travel agent you task with finding the cheapest flight to Paris. It doesn't just tell you the prices, it can monitor them, reason about what the best deal is, and then connect to an airline system to actually book the ticket for you. It acts on your behalf.
But wait, how do we make sure these autonomous agents behave correctly and, safely? We use a technique called reinforcement learning with human feedback, or RLHF for short. In this process, human raters are basically giving a thumbs up or a thumbs down to the agent's actions and its responses. Over time, all that feedback reinforces the good behavior and it penalizes the bad stuff, teaching the agent to align with what we actually want it to do.
Finally, let's talk about the practical side of all this. How do we put these powerful tools to work in the real world? And what's just over the horizon? Let's get a little glimpse of the future.
One of the most fascinating evolutions we're seeing is the rise of reasoning models. See, a standard LLM is trained to predict the next word and just spit out a direct answer. A reasoning model, though, is trained to think step by step. It actually shows its chain of thought, breaking down a complex problem. And for businesses that need to audit or understand how an AI got to its conclusion, this transparency is a huge, huge deal. For a lot of businesses, a massive, general-purpose LLM is like using a sledgehammer to crack a nut. It's just overkill. And that's where small language models, or SLMs, are coming in. They are a much more efficient solution for specialized tasks because, as you can see, they are way smaller, so much cheaper to run, and they can be trained to become deep experts on your specific company data.
Now, one of the biggest hurdles in deploying any AI model is its sheer size. They take up a ton of memory and processing power. But there's a crucial optimization technique called quantization, and it can reduce the model's memory requirements by up to 75%.
And this perfectly illustrates a core engineering trade-off. Quantization is kind of like compressing a very large, very precise number into a smaller, slightly less precise one. The upside is massive. Your model becomes smaller, faster, and way cheaper to run. The potential downside? A slight dip in accuracy. This is the kind of critical decision every developer faces when they're trying to balance performance and cost in the real world.
So, where is all of this headed? Well, the future is absolutely multimodal, with AIs that can see and hear and create, which is going to totally transform content creation. It's moving towards truly autonomous agents that manage entire business workflows, which of course makes data privacy a critical challenge we have to solve. And behind the scenes, we're already exploring brand new architectures like state space models that could one day outperform the transformer.
We've covered an incredible amount of ground today, right? We went from a single token, just a piece of a word, all the way to an autonomous agent that can actually act in the real world. These are the fundamental building blocks of modern AI. So the only question left is, what are you going to build with them?
Thanks for watching.